Hi, I'm Detective Incognito. Welcome to another investigation. I explore strange events, forgotten discoveries, and questions that still challenge what we know about our world. What you're about to hear might change the way you see everything. 2023. Scientists proved your brain cannot tell the difference between imagination and reality. Over 600 participants were fooled by their own neural architecture. When asked to distinguish what they imagined from what they actually saw, they couldn't. The boundary between real and imagined became indistinguishable. At the neurological level, this wasn't philosophical speculation. It was experimental observation that fundamentally challenges how we understand perception itself. Subscribe now to discover how your brain constructs the reality you think is real, and why that construction might not match external truth. Like this video, if you want to understand why seeing truly isn't believing. The story begins at University College London, with an experiment that would reshape our understanding of consciousness. In April 2023, Nadine Dijkstra published findings in Nature Communications that disrupted conventional thinking about perception. Her team recruited over 600 participants for an online experiment, testing the boundaries between imagination and reality. The task appeared simple. Participants stared at screens and imagined alternating black and white lines appearing before them. They reported how vividly they could visualize these imagined patterns. But the experiment contained a secret twist. While participants focused on imagining the lines, real visual stimuli gradually faded onto their screens. The actual patterns mixed seamlessly with imagined ones. Participants were then asked a crucial question. Was what they experienced real or imagined? The results were striking. People couldn't distinguish between the two. When real stimuli appeared, participants didn't recognize external reality intruding. Instead, they believed their imagination had simply become more vivid. The imagined and perceived stimuli became intermixed in ways participants couldn't untangle. Dijkstra used computer modeling to understand the mechanism. The brain judges whether something is real based primarily on vividness, rather than any categorical distinction between internal and external sources. Neuroimaging validation confirmed that brain regions encode imagination and perception using identical neural circuits. Dijkstra's conclusion challenged fundamental assumptions about consciousness. There is no categorical difference between imagination and reality. At the neural level, the distinction is one of degree rather than kind. When imagination becomes sufficiently vivid, the brain treats it as perceptual reality. This finding wasn't merely academic curiosity. It explained phenomena ranging from vivid dreams feeling real upon waking, to how mental imagery can trigger genuine physiological responses. While Dijkstra's work focused on human perception, researchers at UC Berkeley investigated the neural mechanisms, creating illusory realities. In September 2025, Hye-Young Shin published findings in Nature Neuroscience, identifying specific neurons responsible for generating perceptual illusions. Working with Hillel Adesnik and using the Allen Institute's Open Scope program, Shin studied how mouse brains process the Kniza triangle illusion. This classic visual trick uses four Pac-Man-like shapes, arranged to create the perception of a triangle that doesn't actually exist. The shapes merely suggest boundaries. The brain completes into a coherent object. Shin discovered that neurons in the primary visual cortex, specifically IC encoder neurons, drive this process. Through what researchers call recurrent pattern completion, using holographic lasers, the team stimulated these specific neurons artificially. The result was remarkable. Stimulating IC encoder neurons alone created the illusion, without any actual visual stimulus present. Brain activity when perceiving the illusion was virtually identical to brain activity when viewing an actual triangle. The finding revealed something profound about how vision works. The illusion doesn't originate in the primary visual cortex. Instead, it emerges in higher visual processing areas that recognize patterns in objects These higher areas then feed information backward to V1 through IC encoder neurons, completing the pattern based on expectation rather than input. Pattern completion explains why brains fill perceptual gaps automatically. Vision isn't passive recording of external reality. It's active construction, where the brain constantly predicts what should be present. Based on incomplete information, Jérôme Lecoq at the Allen Institute emphasized the clinical significance. Understanding how object representations emerge could illuminate psychiatric conditions, where the brain generates false perceptions indistinguishable from reality. The constructed nature of perception extends beyond vision alone. In 2013, researchers at Karolinska Institutet in Sweden demonstrated that imagination in one sensory modality can alter perception in completely different senses. Christopher Berger, then a doctoral student, worked with Henrik Ehrson to conduct 3 experiments using cross-sensory illusions. In the first experiment, participants watched 2 objects move toward each other. When participants imagined hearing a collision sound at the moment the objects touched, they reported seeing the objects collide and bounce rather than pass through each other. Imagination of sound changed visual perception. The second experiment reversed the relationship. Participants heard sounds while imagining seeing a white circle at specific locations. Their spatial perception of where the actual sound originated shifted toward where they imagined the visual stimulus appearing. In the third experiment, participants watched someone speak while imagining specific sounds. Their perception of what the person actually said changed to match their imagined audio. Ehrson described these as the first experiments definitively establishing that sensory signals generated purely by imagination are strong enough to change real-world perception in other sensory modalities. The brain doesn't maintain strict boundaries between imagination and perception, even across different senses. Instead, it combines all available information, whether internally generated or externally received, into a unified perceptual experience. This explains phenomena athletes exploit when using mental imagery for pain management and performance enhancement. It also illuminates psychiatric disorders, where patients cannot distinguish internally generated thoughts from external reality. The mechanism isn't malfunction, but normal operation of perceptual systems that evolution designed for integration rather than segregation. Perhaps the most unsettling demonstration of constructed reality came from Japanese researchers in 2012. They developed the substitutional reality system, designed to test whether people could distinguish live experiences from pre-recorded ones. Participants wore head-mounted displays showing video feeds. The system alternated seamlessly between live camera feeds and pre-recorded footage, particularly during head movements when people naturally expect visual changes. 21 participants experienced the system without prior knowledge of its deceptive nature. The results were absolute. 100% believed pre-recorded scenes were happening in real time. No participant detected any reality gap. Psychophysical analysis revealed that depth perception didn't affect people's ability to discriminate. Scene switching during movement enhanced the substitution by matching expected visual changes to head motion. The system demonstrated that the brain prioritizes perceptual coherence over accuracy. If an experience flows smoothly and matches expectations, the brain accepts it as real, regardless of whether it reflects current external reality. This has profound implications for understanding consciousness. What makes us certain something is happening now, rather than being a recording or memory? The answer isn't objective verification. It's the brain's interpretation of whether the experience fits coherent patterns. What these experiments collectively reveal is that reality as we experience it is the brain's best guess, rather than direct observation of objective truth. Patrick Kavanagh at Dartmouth summarized this succinctly. We're not seeing reality. We're seeing a story being created for us. Evolution shaped perception for survival rather than accuracy. The brain constructs perceptual experience by combining prior experiences, expectations, and current sensory input through mechanisms that prioritize useful fiction over objective truth. Multiple experiments across decades from different research groups converge on the same principle. Two people can experience identical stimuli, yet perceive entirely different realities. Neither is wrong. Their brains simply construct differently. Understanding this becomes crucial for developing artificial intelligence systems, treating psychiatric conditions, and evaluating legal testimony. It doesn't diminish reality or reduce experience to illusion. Instead, it explains the true nature of perception as an active, creative process. Your brain doesn't show you reality. It creates a useful fiction optimized for survival and function. That fiction is coherent, consistent, and convincing. And critically, that fiction is the only reality you will ever know. The question isn't what's objectively real. The question is whose constructed reality we're discussing. If you liked what you just saw, like the video, subscribe to the channel, and activate the bell. Leave your opinion in the comments below to let me know what you thought. Thanks for sticking around, and see you in the next video.